This is a 2017 Mathematics Exam 1, and in front of me is an actual copy of the exam booklet. So let's have a look at the 9 questions. Okay, first question, 4 marks. Usually every year it's this one, differentiation. F of x is x on x plus 2. Differentiate f with respect to x. So we could say let u equals to x, v equals to x plus 2. U dash is 1 and v dash is 1. So now we are going to use quotient rule. To get f dash of x is u dash v minus v dash u divided by v squared. So in actual fact, you are going to get, say, 1 times x plus 2. It's one part, subtracting 1 times x divided by x plus 2 squared. Well, we better simplify the top as the simplest term. Say x minus x is 0, so 2 over x plus 2 squared. The other thing is, if you notice, this f of x can be written as, for example, you write x plus 2 divided by x plus 2. Take away 2 divided by x plus 2. And that is 1 minus 2 times x plus 2 to the power minus 1, something like that. Then you can use chain rule instead of quotient rule. So for example, f dash of x is 0 minus 2 times minus 1 bracket x plus 2 to the power minus 2. So you actually get 2 over x plus 2 whole thing squared, okay? Historically, this was a 2 marks question, so you better show some correct use of quotient rule or chain rule here, like the manipulation, and then simplify the answer. And the next one is g of x equal to 2 minus x to the power 3 again. So this is definitely a chain rule. Evaluate g dash 1. Well, before I attempt that, just make sure you realize if you have, say, some kind of function, u of x to the power n, derivative of that function is n times u dash of x times u to the power n minus 1, something along this line. So this is like a chain rule. So therefore, if I'm going to find g dash first, that is 3 times 2 minus x to the power 3 squared. But don't forget you need to multiply by the derivative of the inside. So it's a negative 3x squared, okay? And then you are going to calculate g dash 1. So g dash 1 equals to 3 times 2 minus 1 squared times minus 3 times 1. So eventually your answer should be minus 9, okay? There is no need to expand this result. Otherwise, you just get the result messier. So let's have a look at the next question. Okay, next question is a classic product rule and integration question. So if I take a look at this question, let y equals to x times log e3x by dy dx, and that was a 2 marks question. So basically, if you take in dy dx, this is a product rule. It equals to derivative of x is 1 times log e of 3x plus x times, well, when you differentiate log e 3x, you are going to get a 1 over 3x times 3. So it is important not to miss the multiply by 3 here, okay? And then the 3 and 1 are just canceled. So you actually get log e of 3x plus a 1, okay? And the question says, hence evaluate 1 to 2, log e 3x plus 1. And express your answer in the form log e a, where a is a positive integer. So you're going to use your part a. For example, you notice, if I write that in explicit form, say d dx x log e of 3x is equal to log e of 3x plus 1. Then I can undo the differentiation by integrating both sides. Say integral of log e 3x plus 1 dx. Well, an antiderivative is x times log e of 3x. Oh, well, if I don't put any numbers here, like a 1 and 2, it will give you an add c at the end. That's a general antiderivative. But since we are finding, let's say, a definite integral, then I'm just embedding, let's say, 1 to 2, and then put a 1 to 2 here, right? And then just do the evaluation bit. So for example, I get 2 log e 3 times 2, that's 6, minus 1 times log e of 3, okay? And then we are going to combine two log terms into one as required. So the first term is log e of 6 squared. Second term is log e of 3. Well, next thing is we get a log e 36 divided by 3. So that is a log e of 12. Well, in this case, a is 12. So the problem is solved. And we can move on and look at the next part. Okay, question 3. F of x has a restricted domain, and it's a factorized cubic function. So we want to show that x plus 2 squared times x minus 1 is x cubed plus 3x squared minus 4. Well, you could actually, for example, go from your left-hand side to the right-hand side, which is like a verify approach. For example, the first term is x squared plus 4x plus 4 times x minus 1 equals to x to the power 3 minus x squared plus 4x squared minus 4x. Finally, plus 4x minus 4. Okay, something along this line. So it's like from inside to outside, from here to here. Here, 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 here. Lastly, you have 6 terms. And to show this kind of simplification, so you get x to the power 3 plus 3x squared minus 4. That is equal to the right-hand side. I suppose that's for 1 mark, show that question. Of course, you could actually see, if you go from right-hand side to left-hand side, you might say, okay, x to the power plus 3x squared minus 4. Equals to, for example, if you notice there is an x minus 1, you might say, okay, we have x to the power 3 subtracting x squared. Then you add a 4x squared minus 4 here. Then you can take out an x squared here, and just get an x minus 1. And then you just get, let's say, plus 4 lots of x minus 1, x plus 1. Something along this line. Then you say, okay, x minus 1 as a common factor, x squared plus 4x plus 1. Then you can just recognize this is a perfect square. And that is equal to left-hand side, okay? Whichever way you go, you have to show convincing working, and everything should be correct. Next one, you want to sketch the graph of f on the axis below. Label the axis, intercept, and any stationary point with their coordinates. So just notice the domain restriction is -3 to 0, and you have to notice that you need to address the two endpoints. For example, f of -3 is equal to -3 plus 2, bracket square, and -3 take 1. So that is -1 squared times -4. And that is -4. So the first thing I'm going to mark here is like -3 -4. Okay. And another thing I want to notice is the right endpoint. That is -4. If you recognize this is the y value, 0 minus 4. Okay? And also this is a turning point. Okay. Just be mindful now, you are not going to extend this graph beyond x equals to 0. So I guess what you might get is like this. But you're only restricting from here to here, okay? So eventually, you can also verify when x equals to -1. And that is the graph you want to produce. Just a few things to note, and you need to make sure this one looks like a half turning point, because one way you could recognize this is from the expanded form, like the expanded form f of x. If you take out an x squared, you get x plus 3 and a minus 4. If you just look at this part, so this is minus 3, this is 0. So you may get something like this, okay? Because the x squared, without this minus 4, this x squared indicates a touch at a 0, 0. But once you take a minus 4, it's like shifting everything down by 4 units, okay? And this form is like x plus 2 squared, x minus 1, okay? That's why you have a 1 here. And therefore, this y-intercept should also look like a turning point. Or you can use differentiation to verify what's happening. So f dash of x equals to 3x squared plus 6x equal to 0. And then you get, let's say, 3x times x plus 2 equals to 0. So x equals to 0, x equals to minus 2. And then just subbing and get these 2 points as your stationary points. Okay, let's move on. Question 4 is a very simple 2 marks sampling distribution question. In a large population of fish, the proportion of an angelfish is a quarter. P hat is a random variable representing the sample proportion of angelfish for samples of size n drawn from the population. We want to find the smallest integer value of n such that the standard deviation of p hat is less than or equal to 1 out of 100. So basically, you need to use p times 1 minus p divided by n. That is the standard deviation of p hat. So now, that is a quarter times 3/4 divided by n. Less than or equal to 1 out of 100, okay? So make sure you interpret the sentence in the correct mathematical form. And then you can simplify this expression. The way I treat it is like 1 over n under the square root. And then you get, let's say, 3 divided by 16. 4 times 4 is 16. Less than or equal to, let's say, 1 out of 100. Okay? And then you can simplify everything, like write it like 1 over square root of n times square root of 3 divided by 4. So take out the root 16 as a 4. Less than or equal to that. And then you might want to, for example, rearrange this a little bit, like a multiply by 4 here and a multiply by 4 here. So you get a root 3 divided by root n less than or equal to 1 over 25, okay? And if you flip them the other way around, taking the reciprocal, you actually get, let's say, square root of n divided by root 3 is larger than or equal to 25, okay? 1 over 1 out of 25, this is 25. Then your square root of n is greater than or equal to 25 root 3, okay? And I try to square both sides. For example, n is greater than or equal to 25 squared times 3. So 25 squared is 625. Therefore, 25 squared times 3 equals to 625 times 3. That is 1875. So the answer is n smallest equals to 1875. That is the smallest sample size for us to achieve a standard deviation less than or equal to 1 out of 100. Okay, question 5. For Jack to log on to a computer successfully, Jack must type the correct password. Unfortunately, Jack has forgotten the password. If Jack types the wrong password, Jack can make another attempt. The probability of success of any attempt is 2/5. Assume that the result of each attempt is independent of the result of any other attempt. A maximum of 3 attempts can be made. Let's say S is success. N is failure. What is the probability that Jack does not log onto the computer successfully? So you can try, okay, success, failure. If you failed once, you can still try another time. Success, failure. And the last time, if you fail the second time, you get success, failure. Once you used up all the 3 attempts, you can't make any other attempt anymore. So eventually, if Jack does not log onto the computer successfully, that means he or she failed all the 3 times. So we would like to get, let's say, n, probability n. And each time 2 out of 5, 3 out of 5. Independent means the probability or the proportions that don't change. So you get a 3 out of 5 times 3 out of 5 times 3 out of 5. Okay, something along this line. And then you get a 27 out of 125, okay? Calculate the probability that Jack logs onto the computer successfully. Express your answer in the form A over B, where A and B are positive integers. So basically, it could be the first time, second time, or the third time. Or, let's say, probability S at any attempt equals to 1 takeaway log fail all attempt. And it's like the sum of this case, NS, and NNS, okay, something along this line. So you get 1 takeaway 27 out of 125. And that is 125 take away 27 divided by 125. So you'll be able to get, say, 98 out of 125 as the answer. And the next one is calculate the probability that Jack logs onto the computer successfully on the second or on the third attempt. So second S or third S is like the probability of NS plus probability NNS. Alternatively, you might want to use, let's say, this answer, subtracting successful on the first attempt, okay? I'll put them all here. Probability second S or third S equals to probability S at any minus probability first S. That is 98 over 125, subtracting 2 out of 5. To simplify this result, you might want to multiply 25 and 25 here. So you get a 98 minus 50 divided by 125. So you get a 48 out of 125. Let's try the second approach. So the second, also first approach. The first approach is like 3 out of 5 times 2 out of 5 plus 3 out of 5 times 3 out of 5 times 2 out of 5. Okay. Refer to the probability tree table, tree diagram. Okay. You can multiply 5 here divided by 5 here. So eventually it's going to be 3 times 2 is 6. 6 times 5 is 30 plus 9 times 2 is 18 divided by 1 out of 25, 125. So 48 out of 125. So I actually demonstrated two possible approaches for this one, okay? Question 6, equation solving. The tangent theta minus 1 sine theta minus root 3 cosine theta sine theta plus root 3 cosine theta equals to 0. State all possible values of tangent theta. From the first one, we see tangent theta equals to 1. From the second and the third factor, we will see sine theta equals to either plus or minus root 3 cosine theta. And we can divide everything by cosine theta to get a plus or minus root 3. Therefore, you get a tangent theta equals to plus or minus root 3. So tangent theta altogether equals to 1 or plus or minus root 3. And hence find all possible solutions for tangent theta minus 1 times sine squared minus 3 cosine squared theta equals to 0, where theta is between 0 and pi. Well, this version is like the expanded version, expanded form of the above formula, like sine minus root 3 cos, sine plus root 3 cos, you get sine squared minus 3 cos squared. So that also have the three values we obtained before. They are identical. Firstly, if tangent theta equals to 1, that will give me theta equals to pi over 4 only, because we can only take Q1 and Q2, the first two quadrants. The next thing is, if you have tangent theta equals to root 3, we will have theta equals to pi over 3 only. So like here, this one is like here. And if I have tangent theta equals to minus root 3, well, I can only select the angle from the second quadrant. So theta equals to pi minus pi over 3, that is 2 pi over 3. So altogether, we should have three solutions. Pi over 4, pi over 3, 2 pi over 3. And I try to keep your answers in radians. If you write 45, 60, 120, you should have degrees, but I prefer radian answers. Question 7. Always notice the domain restriction for any function or graph questions. Like this f of x is a square root function. If I just look at, let's say, the full picture, it's like a square root function translating the y into the left. So for maximal domains from -1 to infinity, but we only have 0 to infinity. That means we can only take, let's say, from here to infinity. So therefore, the range is actually 1 to infinity. Okay? And let g be a quadratic function restricted on -infinity to c. We would like to find the largest possible value of c such that the range of g is a subset of the domain of f. Well, range g is a subset of domain of f. So range g symbolically, we just say it's the expression g of x is a subset of 0 to infinity. So I can just transcribe this one as, let's say, an inequality. If g of x is within this 0 to infinity, that means any g of x must be greater than or equal to 0. So you would have x squared plus 4x plus 3 is greater than or equal to 0. And you can factorize this expression, say x plus 3, x plus 1 greater than or equal to 0. So we are trying to solve, let's say, for the possible values of x from this inequality. And if you just draw a diagram, you'll have a -3 here and a -1 here, which means the feasible regions is either x less than or equal to -3 or x greater than or equal to -1. But the way domain was constructed suggests that x is less than or equal to c. So we can only select the matching side, the same direction, rather than the other side, okay? Therefore, matching both inequalities, you get c max, the largest C value is -3. Okay. And for the value of C value in part B1, state the range of fg of x. Well, symbolically, if I just write f of g, that is g plus 1. All x values belongs to -infinity to -3. It is actually coming from g is greater than or equal to 0, and that is the inequalities we used, okay? So if I don't treat g as a function, I treat it as a dummy variable, you will see the g starts from 0, so the g plus 1 starts with 1, so the square root is just starting from 1. Therefore, f of g belongs to 1 to infinity. So it accidentally has the same answer as the first part, okay? Alternatively, if you really want to use an explicit form, I'm going to put another possible method here, which is slightly pushing the boundary. Say fg of x equals to square root x power 2 plus 4x plus 3 plus 1. So this part is g plus 1 came from the original rule of f of x. So you actually get x squared plus 4x plus 4. And this seems to be square root x plus 2 squared. Now, if you are going to simplify this expression, you have to be very careful. This is actually an absolute value of x plus 2, okay? And if you just look at, the graph of this function, this is -2. It's a V-shaped graph. This is a 2. And your x value, this is f of gx, is only up to here. Let me just use a different color. So only this bit, okay? And it's up to, let's say it's 1. So all the y values along this graph is larger or equal to 1, okay? But without using the absolute value, you might be able to get that using some kind of intuitions, okay? Just looking at the rule here, because this is a strictly increasing function. And yep, the last part, fh of x. So if I write fh of x equals to square root x squared plus 3 plus 1. That is square root x squared plus 4. So we can see if x equals to 0, oh, by the way, now the domain is all real numbers. Let's call this y. Y equals to square root of 4, which is 2. If x equals to plus or minus 1, then y is going to be plus or minus 1 squared is 1 anyway, so square root of 5. You can see this value is larger. If x equals to plus or minus 2, y is going to be 4 plus 4, square root of 8, etc., etc. Say if I push x approaching to plus or minus infinity, then y is going to be approaching to infinity anyway, plus 4 out of the square root. So it's still infinity. Therefore, the smallest value is 2, the largest value is infinity. So the range f of h equals to 2 to infinity. And just be careful. This was a paper from the previous study design. In the current study design from 2023 to 2027, you should be familiar with FOG notation like this. That means f of g of x. So the second function is substituted into the first. Or in this case, they might give you some kind of things like FOH bracket x. Okay. Be aware of these two new notations. Okay. Which one is outer, which one is inner? Range of the inner function is a subset of the domain of the outer function. Then this thing is defined, etc. Okay. Question 8 and question 9. I'm going to finish them. For events A and B from the sample space, probability A given B is 1/5, probability B given A is 1/4. Probability A intersecting B is P. Find probability A in terms of P. So that means I may want to use, say, probability B given A is probability B intersecting A divided by probability A equals to 1/4. So I'm using the second equation here, second condition, and the probability A intersecting B is P. Can sub in here, so P divided by probability A equals to 1/4. Therefore, probability A equals to 4P. Okay, so that's one thing. And the other thing is, if I want to find any intersection probabilities or unions, etc., I think the most straightforward method would be, let's say, Venn diagram, or let's say a color map. So if I put an A dash here, B dash here, the bottom right corner is what? Probability A intersecting B is P, and probability of, let's say, A is 4P. So I'm going to get a 3P here, right? And in the same fashion, if I reuse, for example, probability of A given B, that is probability of A intersecting B divided by probability B, that is equal to 1/5. In the same way I obtain probability A, I can put a P here. I leave this Y as an unknown. So P divided by probability B equals to 1 out of 5. Therefore, your probability B is going to be 5P, etc. Okay? So horizontally, I'm going to put a 5P here. That is corresponding to probability B. So A dash intersecting B will be 4P here. This bit will be 1 minus 4P. This bit will be 1 minus 5P. Eventually, 1 minus 4P take 4P is 1 minus 8P. If you check horizontally, these two should add up to 1 minus 5P. Vertically, these two expressions should add up to 1 minus 4P. Yep. So therefore, probability A dash intersecting B dash is 1 minus 8P. Okay? Alternatively, you might want to use, let's say, other methods, but here I think the Venn diagram or color map will be the most suitable way. And finally, if I have probability A union B is less than or equal to 1/5, we want to state the largest possible interval for P. So I'm going to say, okay, think about the opposite. The opposite is 1 minus probability A dash intersecting B dash is less than or equal to 1 over 5. And we can directly use this result here, say 1 minus 8P is less than or equal to 1/5. So eventually you have 8P less than or equal to 1/5, and P is less than or equal to 1 out of 40. And also notice probability A intersecting B equals to P. These parameters should lie between 0 and 1 anyway, isn't it? So it seems that we need to use the 0 as the smallest bound of the largest possible for P. But if you take a closer look, we also had these two conditional probability expression. So the conditional probability is also divided by probability A or probability B. See, probability A has a 4P, probability B has a 5P. So if I put them in the denominator, should I take 0? Not really. Just mention also probability A equals to 4P, probability B equals to 5P, non-zero as denominators of the conditional probabilities. Therefore, your P must be larger than 0. Okay? And eventually, if I combine them together as an interval, P parameter belongs to 0, 1 out of 40. Okay. Okay, so that is my final answer. Round bracket, okay? Try to draw it round. Try not to fudge your round bracket and the square bracket. Otherwise, you may not receive any mark. So let's have a look at the last one. It's 9 marks. Long question. Historically, it was knocked down very well. Last question concerns function involving the square root, root x times 1 minus x between 0 and 1. Here, first one, we want to find the area between the graph of f and the x-axis. So we use integration. And to integrate this function, we can multiply the square root into the second linear function and then write 0 to 1, x to the power half minus x to the power 1 times x to the power half, x to the power 3 halves dx. So you get x to the power 3 halves, 2 over 3 minus 2 over 5, x to the power 5 halves, 0 to 1. And you should be able to get, let's say, 2 over 3 times 1 minus 2 over 5 times 1, subtracting 2 zeros anyway. So you get 10 out of 15 minus 6 out of 15. Put them as equivalent fractions, and you can cancel it down to 4 over 15. So that is the exact answer. For x in the interval 0 to 1, show that the gradient of the tangent to the graph of f is 1 minus 3x divided by 2 root x. Well, this did incur a technical issue for part C and part D. Like, in fact, this graph, if you extend that later, the maximal domain of this function should better be 0 to infinity, because later on, if you could argue if you define this function on 0 to 1, it's not quite differentiable at the right endpoint, okay? But anyway, we're gonna proceed as if the gradient exists. So first of all, f of x is x to the power half minus this is x 3 on 2, okay? Something along this line. Let me write it properly. I shouldn't be using my whiteout. X 3 on 2, okay? Write that nicely. Next thing is I just take the derivative as per normal. So half x to the power minus half. Take away 3 on 2, x to the power half. Then I'm going to write them as fractions and radicals. So the first term is 1 over 2 root x minus 3 root x divided by 2. The next thing I'm going to do is like I try to combine the fractions. So multiply a root x here divided by root x here. Eventually I get 1 minus 3 x divided by 2 root x. So I think the key thing is not only should we get the correct derivative, but also we need to put that in the form, like with the radical, and then show how we combine two fractions with the radicals into the given result, okay? So this result can be very useful. So I'm going to highlight this one. The gradient of the tangent to the graph of f is this expression here. And if we look at the preamble of the question, the edges of the right angle triangle ABC are the line segments AC and BC, which are tangents to the graph of f, and the line segment AB, which is part of the horizontal axis, as shown below, here and here. Let theta be the angle that AC makes with the positive direction of the horizontal axis, where theta goes from 45 degrees to 90 degrees. So basically, if theta is 90 degrees, well, it's like that. It's like a vertical tangent. We don't want that. So we want this ruler to move along the curve like this, while we have a, not a tangent like this, okay? Find the equation of the lines through BC in the form y equals to mx plus c for theta equals to 45 degrees. So technically speaking, if theta equals to 45 degrees, that is, okay, I just use my pencil to draw what's happening here, okay? So this is a 45 degrees, and then we know we can get, let's say, another triangle, another side of the triangle, but this is still a 90 degrees angle, okay? So if that's 45 degrees, we say M1 equals to tangent 45 degrees, which is 1. And we have obtained, let's say, the gradient form from previous part. So we just equate the gradient f dash of x equals to 1 minus 3x divided by 2 root x equals to 1, okay? And then we try to rearrange this equation, say 1 minus 3x equals to 2 root x, and then push everything to one side, say 3x plus 2 root x minus 1 equals to 0. Now, instead of making a substitution or squaring both sides, which could generate extraneous solutions, I'm gonna rewrite it slightly differently. I'm saying x is root x whole thing squared, and I treat it like a hidden quadratic. So you might get a 3 root x and a root x as a product. And then to get a plus 2 in the middle, I might get a plus 1 and a minus 1 here, something along this line, okay? And yep, that is one thing you might want to do, okay? But actually, we like the line BC instead of AC. So I better make this one like a minus 1. This one is minus 2 root x. And if I push that through, this should be a negative. This should be a negative. So I'm going to get a plus 1 and a minus 1. Bear with me. M2 should be a minus 1, okay? Because they are perpendicular to each other. Product is minus 1. And then we should get 3 root x plus 1 bracket, and then root x minus 1 equals to 0. Root x equals to minus 1/3, reject, because a positive square root cannot generate a negative value. The other case is root x equals to 1 and x equals to 1. So if x equals to 1, on the graph, f1 is 0. That is the x-intercept. So the line is y equals to minus 1 times x minus 1 plus 0. And if you simplify that, that is y equals to minus x plus 1 for the equation BC for that particular angle. And if I want to find the coordinate of C where theta equals to 45 degrees, well, this is what I'm going to do. So f dash of x is 1 minus 3x divided by 2 root x equals to 1. In a similar fashion, I just noticed the procedure is very alike, but the only thing is now we have a positive 2 root x. So I should have 3x plus 2 root x minus 1 equal to 0, and a 3 root x, a root x. This time I'm going to use minus 1 and a plus 1 as the factorization combinations, okay? And then I should be able to get a root 3 root x minus 1, root x plus 1 equals to 0. So root x equals to 1/3 only. root x is not equal to -1. Just knock that out. So my x value is 1/9, okay? And the y value is f of 1/9. So it's root x, that is 1/3 times 1 minus 1/9, which is like 1/3 times 8/9. So you get 8/27, something along this line. What does that do? That actually finds me the tangential point, okay? The tangential point. So at this point, I'm able to get, let's say, 1/9 and 8/27. The other thing is, if I really want to find, let's say, the point of intersection C here, I need to find this equation, and the other equation was found before. I just put them together, solve simultaneously. So the tangent AC is y equals to 1 times x minus 1/9 plus 8/27, which is like y equals to x minus 3/27 plus 8/27, and y equals to x plus 5/27, something along this line, I suppose. And then, what else can I do? I can just say, okay, solving these two equations, let's call this 1, this is 2, okay? So 1 and 2 simultaneously to find an intersection C. For example, I can equate minus x plus 1 equals to x plus 5/27. You just rearrange, you get a 2x, both sides add in x, 1 take away 5/27. That is 1 take away 5/27. 27 take 5, 22/27. So therefore, x equals to 22 divided by 2, 11/27. And the next thing is I'm going to solve into one of the equations, say this equation. This is xc, yc is 11/27 plus 5/27, which is 16 divided by 27. So therefore, point C is at 11/27, 16/27. And the problem's done. Okay? All right, so that is pretty much what we need for this question. I do notice only a handful of students could use, let's say, some kind of a midpoint approach. I'm going to show you here. They could say once they figured out this point here, this tangential point should be the midpoint between here, let's call it P, and this C dash. Then they just double up, let's say, the y value, and they double up the horizontal distance to get the actual coordinate of C. But that is a very, very smart but a very rare method. So I believe you need to use your derivative, equating the derivative to the gradient and find the, for example, tangential point of tangency, then sub it back to form the equation of tangent, eventually just form two tangents intersecting at one place. That's it for the 2017 Mathematics Exam 1 Workthrough. So I'll see you in another time. Bye.